So f prime of x, just to remind you, is the slope function of f of x. F prime is the slope function. So when this graph, f prime, is below the x-axis, that means f has a negative slope. When this graph is above the x-axis, f has a positive slope. And then when this graph is equal to 0, f will have a slope of 0. So my graph of f is going to start over the interval from negative infinity to negative 6. The graph of f will be decreasing. And that's because f prime is less than 0. Then we have a slope of 0, and we change direction. So here f prime is f prime is positive. So that means the slope of f will be positive. And then at negative 4, we have a slope of 0. And then we're going to have a negative slope until negative 2. And then at negative 2, I have a slope of 0. So these are like kind of maxes and mins types of things. But at negative 2, we are still going to have a slope that is negative. So at negative 2, I do have a slope that's equal to 0, but then it's going to still be a negative slope after that. So my function is still decreasing until negative 1. And then it's still decreasing at negative 1. But what I wanted to point out is because the slope is exactly negative 2 and is constant, what that means is that f is going to turn into a line. So like here we've got a bunch of curves, but then at x equals 1, from 1 until 3, we have a slope that's exactly negative 2. So your graph is going to look slightly different than mine. That's totally fine. But the idea is, are you decreasing where you're supposed to be decreasing? Are you increasing where you're supposed to be increasing? And are your slopes, do you have, tangent lines that are horizontal at these locations? So it's, it's just a sketch. Okay. And then at x equals 3, we have kind of this jump here, right? So all of a sudden my slope is exactly 1. So what that means, and that's going to be right until there. So my graph looks something like this, where my slope is equal to 1. And you'll notice that on f prime, we have kind of a jump discontinuity here. I'm doing my best to graph this, even though these should really be open circles. So it's not the best because you can't have like an endpoint and be differentiable at that point. So technically f prime should not exist at those two locations. They should be holes. But that's okay. We have the general idea. The point is draw a sketch, make sure it looks something-ish like this. And then you're fine. Okay, now for f double prime, so this is going to be different. Now I'm looking at where f prime is increasing, f double prime will be positive. So f prime is increasing until negative 5. It's increasing from negative 3 until negative 2, and then that's it. And then it's decreasing from negative 5 to negative 3 and from negative 2 to negative 1. I'm sorry, positive 1. And then we have a constant slope here and here. So the graph is going to look like this. F double prime will be positive from negative infinity until negative 5. So it's going to be positive until negative 5. Then it's going to be negative until negative 3. And then it's going to be positive until negative 2. And then here's the thing. we kind of have had like nice curves up until there. So that's why this one kind of has like a nice curve to it. But then at -2, you'll notice something kind of strange occurs. At -2, we have this like change where it goes from like something that's nicely curved to a line. So our function is not differentiable at this point. It is not differentiable because on one side the slope is like positive, it looks like it's +4 maybe. And then on the other side, the slope is all of a sudden -2/3. So what that means is we are going to have some holes here. So in fact, I'm going to amend my graph a little bit. I do not have a slope of 0 here. My slope is positive. It's not like changing direction. So I'm just going to say it increases and then has a hole. Because again, it's not like this is changing directions nicely at -2. It's just this kind of weird cusp is what we call it. So whenever you have a cusp, which is like where a line meets a curve, that means that it's not differentiable. The function is not differentiable at that point. So on the derivative graph, it would be a hole. And then we have a slope that's -2/3. Okay. Now that is, sorry, I'm trying to color coordinate this. Okay. So I have a negative slope down 2/3. So from -2 to 1, I have a slope of exactly -2/3. So -2/3 is like right about here. Okay. And again, I'm going to have a hole on this side because it's not differentiable. My function is not differentiable at a cusp. And then at 1, all of a sudden, my slope goes from -2/3 to now on the right-hand side, the slope is exactly 0. So it looks like this. There's like a jump where now my slope is exactly 0 until 3. And then my slope is still 0 up here, right? But the point is, the function is not continuous at +3. So I'm going to have to put a hole there. And then my slope is 0 until 5. And then at endpoints, I do not have a slope. So I have to make it an open circle. So it's a good idea if you can color coordinate to do so. But again, I'm just going to go over this with you. When your function is increasing, that means your derivative is above the x-axis. Okay. When your graph is decreasing, that means your derivative is below the x-axis. At corners and cusps and endpoints and discontinuities, those points, and I kind of drew holes on them. I shouldn't have done that. These points do exist on f prime, but they do not exist on f double prime, the derivative. So if you have a corner or a cusp or a discontinuity of any kind, then you're going to have a hole